So today we will start with the refraction. So reflection part we had done, right? So today we start with the refraction. So here we will try to study what is refraction. Then we will try to study about the lateral shift, and then we have the lenses like convex and the concave lenses. Okay. So first we will try to study what is the basic difference between the reflection and refraction. So refraction, like what is the phenomenon of refraction? Bending of light. Why it bends? Change in medium. So refraction, it is the phenomenon. Okay. So refraction, it's a phenomenon in which light travels from one medium to the other medium. Okay. See again, I repeat. Refraction, it's a phenomenon in which light travels from one medium to the other medium. When it travels from one medium to the other medium, light tends to bend. So this we call it as the refraction. Okay. So refraction is a phenomenon in which light tends to bend when it is moving from one medium to the other medium. Okay. So why it will bend when it is moving from one medium to the other medium? Because light, okay, the speed of the light or the velocity of the light, it depends on the medium. Okay. The velocity of the light depends on the medium. So when light is traveling in air, for example, when light is traveling in air, so it will be with some speed, that is 3 into 10 to the power of 8 meters per second. So when it moves to the other medium like water, there the speed reduces, that is the speed changes there. Okay. So when the speed of the light changes, it tends to bend. So this phenomenon, we call it as refraction. Okay, in the lenses, what we see is the refraction. In the lenses, what we see is the refraction, whereas in the mirror, it is reflection. Okay, so in a mirror, what happens? Light will hit the mirror and it reflects back. It reflects back. So it is traveling in the same medium. Whereas the refraction, refraction. So refraction, what happens in a lens? Light passes through that glass. Correct? A lens usually made up of a glass. So or it passes through the lens. So when it is passing through the lens, light first travels in the air, then it passes through the glass, then it passes through the air. So there is a refraction. Whenever light is traveling in a lens, it is a refraction. And when light falls on the mirror, that is a reflection. So when you are writing the exam also, wherever the lens comes, it is refraction. And wherever the mirror is there, it is reflection. That words only you have to use. Okay, because both are the different phenomena. First, refraction. It is a phenomenon. It is the phenomenon in which light tends to bend. Light tends to bend when it is moving from one medium to the other medium. When it is moving from one medium to other medium to other medium. So, what is the reason for the bending of the light? Because light, when it is moving from one medium to the other medium, actually the speed of the light mainly depends on the medium. The speed of the light, it will not depend on the frequency or the wavelength. Okay. The speed of the light depends on which medium it is traveling. So when it is traveling in air or vacuum, it is around 3 into 10 to the power of 8 meters per second. And when it is traveling in any other medium, So it will be different. So maximum speed will be in the air or the vacuum. That is 3 into 10 to the power of 8 meters per second. Okay. So it will be traveling, whenever traveling from one medium to the other medium, what happens? Its velocity will change. When the velocity changes, from what happens? It tends to bend. So that phenomenon, we call it as refraction. Okay. Right, cause of a refraction. Speed of light is different in different medium. Is different in different medium. That is more in rarer medium, right? More in rarer medium, and comparatively less, less, okay, and comparatively less in the denser medium. Example for the refraction, right on the bottom of the pool, the bottom of a pool or a pond pond containing water appears to be raised.
Ma'am, what do you mean by rarer medium?
I will explain. Rarer medium and denser medium. It is a comparison what we do. For example, light is moving from air to water. Okay, so velocity of light in air is more when compared to velocity of light in water or glass. Okay, so there the rarer medium is air and the denser medium will be water. So when light denser and rarer medium, it is a comparison. For example, if two students have got 80 and 90, what we tell the other student is 90 who has got 90, it is better marks. Just a comparison. If another person who have got 95, if you see, compare between 90 and 95, they say better, 95 is better, like that. It's just a comparison. Similarly, denser and rarer means whenever light is moving from one medium to the other medium. Okay, when light is moving from one medium to the other medium, then, for example, it is moving from air to water. So, light, the velocity of light in air is more when compared to velocity of light in the water. So, there, air will be the rarer medium. Air will be the rarer medium, whereas the water will be the denser medium. Okay. Another example, if you take light is moving from water to glass. Okay. In glass, velocity is less. We will get different types of glass. In this water, the velocity of light in water is more, and in the glass it is less. Then here, when comparing these two, the denser medium is what? Can you tell which is the denser medium in water and glass now? Yes, glass is the denser medium. Because light, when you compare these two, light moves faster in the water when compared to glass. So this is a denser medium. Denser means it goes slower. You can think like that. Rarer means it goes faster. So here glass is the denser medium, water is the rarer medium. That is the way you explain. Okay, understood? Now we know that light will bend. Okay, so in which direction it will bend? So light will bend when it is moving from one medium to the other medium. So in which direction it will bend and how much it will bend. Okay. So when you compare, for example, light, think it is moving from rarer to denser. Think light is moving from rarer medium to the denser medium. Rarer medium to denser medium. Okay. In this case, light bends towards the normal. In this case, light bends towards the normal. This is the normal line. Okay. This is the interface. That is the line between the two medium. Okay. So light, when it is moving from rarer medium to the denser medium, then it bends towards the normal. Actually, light should go like this, right? It should go straight like this. It is bending, so it will bend towards the normal. When light is moving from denser to rarer medium. Okay. Denser to rarer medium. So what happens? Light bends away from the normal. Actually, it should go straight like this. It is bending away from the normal. Okay, understood? So it bends away from the normal. So these are the two cases. Then how much it will bend? When the difference in the velocity is more, the bending will be more. When the difference in the velocity of the two lights, okay, if it is more, then bending will be more. So which direction means what? From it is moving, first thing, when it is moving from rarer to denser. Rarer means light moves faster. Denser means light moves slower. Okay. So when the light is moving from rarer medium to the denser medium, it tends to bend towards the normal. And when light is moving from denser medium to the rarer medium, it tends to bend away from the normal. And how much it will bend? It depends on the difference in the velocities of the light. Okay. If the two mediums are such a way that the difference is more in the velocities, then the bending will be more. And here also, this is angle of incidence, this is angle of refraction. And always the angle you have to take with respect to normal. You should not take this side I. Okay, always you have to take the angle with respect to the normal line. What is a normal line? It is a 90-degree line or a perpendicular line drawn for the interface. Okay, normal is a perpendicular line drawn for the interface. See, this is air and this is water. This is a line interface. So this normal is what? This is a 90-degree line for the interface. Clear? When light travels from a rarer medium to a denser medium, light bends towards the normal. When light travels from a denser medium to a rarer medium, light travels away from the normal. Next, loss of refraction. Loss of refraction. Write down this. So, incident ray, the refracted ray, the incident ray, the refracted ray, and the normal. And the normal. To the interface of two transparent medium at the point of incident all lie in the plane, all lie in the same plane, all lie in the same plane. Second one, the ratio of sine of angle, the sine of angle of incidence to the sine of angle of refraction of light of given color is constant for a given pair of media. Okay, that is mu is equal to sin I by sin R. Sin I by sin R. Okay, it is also called as Snell's law. It is called as Snell's law. So one more question, they may ask about laws of reflection, or they may ask like explain Snell's law, like that. So then Snell's law is the second one. Okay, Snell's law is the second one. Right. The constant mu is known as refractive index. Refractive index. Okay, it is known as refractive index. Refractive index. So loss of refraction, loss of refraction. So incident ray, the refracted ray, and the normal. Okay. At the point of incident, they all are in the same plane. That is, if it is in the XY plane, even the incident ray is in XY plane, then the refracted ray is also in the XY plane. It will not change its plane. That it is trying to tell. Okay. So incident ray, the refracted ray, and the normal, all at the point of incident, they all lie in the same plane. They will not change its plane. So that is about the first law of refraction. Second law, see, in the reflection we studied angle of incidence and angle of reflection were the same. Do you remember reflection we studied? Angle of incidence and angle of reflection was same. I is equal to R. But here, the ratio of sine of the angle. When we do the trigonometry, you will know sine ratio, how you will take there. Okay. So the ratio of sine of I, okay, by the sine of R. R is the angle of refraction. That will be always constant for any given pair of the mediums. That is, like, think light is going from water to glass. Okay. So it is always that value will be constant, sin I by sin R. Whatever may be the angle of incidence, so the sin I by sin R will be always a constant. That we call it that constant We call it as mu here, the symbol mu. Okay, that is also called as the refractive index. That is also called as the refractive index. And one when to get it as a constant, one thing you should have the like same pair. See, think one angle of incidence is 60 degree. Okay, so according to that, the bending will be there. So from if light is going from water to glass, so if angle is 60 degree, there also sin A by sin R will be equal. Think in the other one, like from water to glass only, angle of incidence is 70 degree. There also sin A by sin R will be constant. So for any given pair of medium, if it is going from water to glass, so that mu value will be constant for any angle of incidence. Okay, for any angle of incidence, that mu value will be constant, and that will we call it as refractive index. So that actually will tell you the how much it will bend. That mu or that constant value, what you will get, right? That will indicate how much the light will bend, whether towards the normal or away from the normal. But how much it will bend, that depends on this constant. That constant will determine that. Okay, and how it like if it bends more or less, it depends on the difference in the velocities, the difference in the velocities of the light. For example, if light is moving from air to glass, think that is a very denser glass, then the velocity difference will be more. So then bending will be more, and this mu constant will be more, like that. Mu constant will be more. Okay. So this law, second law of refraction, we also call it as a Snell's law. Snell's law. Okay. Sometimes in the exam they tell it as a Snell, explain Snell's law like that. For 1 mark questions. Sometimes they ask. Write down this. Refractive index. Refractive index. The extent of the change in direction, in the direction of the ray of light, okay, that takes place in a given medium, in a given pair of media, is expressed in terms of the refractive index. Mu is equal to velocity of incident light by velocity of refracted light. Okay, mu is equal to velocity of incident light by velocity of refracted light. And this is also equal to sin I by sin R. So mu value you can calculate by knowing the velocity of incident light by refracted light, or by the angle also. You will get the same value. However you calculate, you will get the same value. And if that mu value is more, that indicates bending is more. Mu value is more, that indicates the bending of light is more. Okay. While telling that, think, for example, you have this is medium 1, this is medium 2. Okay, light is moving from medium 1 to medium 2. Light is moving from medium 1 to medium 2. Then, while calculating the refractive index, we tell it as a refractive index of 2 with respect to 1. Okay, when we are writing, how we write is the refractive index of 2 with respect to 1. That means light is going from medium 1 to medium 2. But while indicating how we write is refractive index of 2 with respect to 1. Understood? That way we write. Whenever they give like refractive index of any from one with respect to the other, so that indicates that light is going from medium 1 to medium 2, like that. Because in problems and all, they specify like that. Next, write absolute refractive index. Absolute refractive index of the medium. The refractive index of a medium with respect to vacuum is called absolute refractive index. Absolute refractive index. Okay, what do you mean by this? What do you mean by this? Absolute refractive index. So, Naina, what do you mean by this? Aditya, what do you mean by that absolute refractive index? See, whenever light is moving from vacuum to any other medium, whatever mu value you will get, that we call it as absolute refractive index. So, whenever light is moving from air to air or vacuum, it is the same. What we consider that is 3 into 10 to the power of 8 meters per second. We also call it as C. Okay. So light is moving from air or vacuum to any other medium, right? Whatever mu value we get, that we call it as absolute refractive index. See, for example, water, mu W, if you consider, mu W, if you consider, that means light is moving from, it is the absolute refractive index. Okay, light is moving from air to water. So its value we consider, or mu G. Here, mu G means what? Light is moving from air to glass. So what is its value? That value we call it as absolute refractive index. Okay, so why we take like that? See, from air to glass, then water to glass, then water to diamond, water to kerosene, like that. If you consider many pairs, it is like too many values we will get. So always only the reference things what we consider is the absolute refractive index of water, glass, diamond, kerosene, like that. Only that we consider. From any two pair, we try to find the value. Okay, that value we call it as absolute refractive index. Refractive index. Okay. So refractive index of glass with respect to air. So what does it mean? Light is going from air to glass. Okay, light is moving from air to glass. So that we call it as here the refractive index of glass with respect to air. Okay, we call like that. So this is an absolute refractive index of the glass because light is going from air to glass. So here mu Ag will be equal to velocity of light in air by velocity of light in glass. Earlier we wrote, right, remember, velocity of incident ray by velocity of refracted ray. Velocity of incident ray by velocity of refracted ray is the thing which we call it as mu. Correct? So here also we have written the same thing. Here the incident ray is in air. Okay, refracted ray is in glass. So velocity of light in air by velocity of light in glass. So symbol we write like this, mu, air here and the glass. So refractive index of glass with respect to air like that. Okay. Next one with refractive index, write on this. Refractive index of water with respect to air. Refractive index of water with respect to air. So this is velocity of light in air by velocity of light in water. In water. Okay. So here also this usually velocity of light in air we call by the symbol C. Okay, this is Vg. C by Vw. So next. Write down this. Is equal to C by C by Vw by C by, write down this, I'll explain. Vg. C by Vw into Vg by Vw. So now here we are trying to calculate by the absolute refractive index. Now we are trying to calculate when light moves from glass to water. Light is moving from glass to water. What will be the refractive index at that time? Okay. So think light is moving from glass to water. Okay. So for any given pair, only we consider the refractive index, correct? And that will indicate the how much it will bend. So from glass to water, if it is going, how to calculate velocity of glass by velocity of water, because incident ray is in glass, refracted ray is in water. So that will give you the refractive index of here, refractive index of water with respect to glass. How we call. Okay, so how to calculate that? Usually anywhere the table they give the absolute refractive index. Anywhere the table they give the absolute refractive index value. So first consider the light, absolute refractive index of glass. How much it will be? Velocity of light in air by velocity of glass in glass. So that is C by Vg, correct? Some value they will give. Then absolute refractive index of water, if you know, that will be equal to velocity of light in air by velocity of light in water. That is C by Vw. Now, if I divide C by Vw by C by Vg, how much you will get? That is absolute refractive index of water by absolute refractive index of glass. So what you will get? C by velocity of water by C by velocity of glass. So this is denominator. When it goes up, these C value we will cancel. We will get Vj by Vw. So light is Vg by Vw means what? Light is moving from glass to water. That we call it as absolute refractive index of water with respect to glass. So if you know the absolute refractive index of any two, from that we can calculate the light like moving from one medium to the other. Write down one problem. It's related to this. Light enters from air to diamond, from air to diamond with refractive index 2.42. What is the speed of light in diamond? Given speed of light in air is 3 into 10 to the power of 8 meters per second. Try this. How to calculate here? So light enters from air to diamond with refractive index 2.42. That is the absolute refractive index what he has given. And he has given velocity of light in air. So you have to find velocity of light in diamond. See, whatever we have done the theory, no, in that only it's there. Check, like just read and do. No, what will be the value? Which formula you can use here? But which one you use? Which one you use? See here, absolute refractive index means what? Light goes from air to other medium. Here he is telling about the from air to water. Whenever they give refractive index, always it will be, most of the time it will be absolute refractive index only they will keep. Okay. And he is directly telling air to diamond it is going. So it is the absolute refractive index only is telling. So from air to diamond, it is moving. So what that value he has given as 2.42. Okay. So what does it mean? Light, this is also equal to velocity of light. Velocity of light of the incident light, correct? Velocity of the incident ray by velocity of the refracted light. Refracted ray, correct? We studied this. Velocity of incident ray to the velocity of refracted ray is the mu. Okay. So mu value he has given 2.42. And velocity of the incident ray is what? Velocity of light in air. Correct? So that is equal to 3 into 10 power 8 meters per second. Now, by velocity of the refracted light. So, that is velocity of light in diamond. Because refracted ray is in diamond, correct? So, it is velocity of light in the diamond. It is the refracted. So, now, what is the velocity of light in diamond now, that will be equal to 3 into 10 power 8 by 2.4. Okay, calculate now. Just divide 3 into 2.42. Okay, 10 power 8, you can keep it as it is. So it is, I can write this as 300 by 242 also, correct? Multiply both numerator and denominator by 100, I will get 300 by 242. Just do the division, direct division, you will get. So that it is equal to, if you divide, you will get 1.24. Okay, into 10 power 8. Understood the calculation? So 3 into 10 power 8 divided by 2.42. So what I will do, I will multiply both numerator and denominator by 100. I will get 300 by 242. This 10 power 8, keep it as it is. The direct division you do, you will get 1.24, that into 10 power 8 meters per second. Understood? You have doubts? Okay. I didn't understand. 3 into 10 power 5, you are telling. 300 into 10 power 5. 10 power 10. You can do. You can't. When you multiply by 100, you are also multiplying same thing, numerator. Then even the denominator, you have to multiply by same number. You will get the same answer. Okay. Then next one, refraction through a rectangular glass slab. Refraction through a rectangular glass. Okay. First reason, then we can write about it. See, rectangular glass slab, how it will be there. So it is a rectangular glass slab. You can consider even like this. With some thickness, it will be there. Okay. So what happens? Incident ray. You fall on this. So light is moving. Think here it is in the air. Correct. Light is moving from air to glass here. So air will be always a rarer medium when compared to any other medium because light in the highest velocity is in vacuum or air. Okay, so velocity of light is maximum in air or a vacuum. It is approximately 3 into 10 power 8. For both, we will consider the same thing. Okay, it is the maximum we get. So in air, it will be always rarer when compared to any other medium. Okay, so light is going from air to glass. So whether it bends towards the normal or away from the normal, it is going from rarer to denser towards the normal. Correct. So it moves towards the normal. Should go like this, but okay, it moves towards the normal. Now, again, it incidence on the other face of the slab, rectangular slab. Okay, so now this refracted ray will be the incident ray for the. Now light is going from denser to rarer, correct? Because it is going from glass to air. From glass slab, it is trying to go back towards the air. See, there is one glass slab here. Okay. So first light goes from air to the glass. From glass, it is going out to the air. So first time what happens? It is going from rarer to denser. Second time it is going from denser to rarer. Okay. So first time it bends towards the normal. Second time it bends away from the normal. Okay. And also one thing what we observe here is both has the same medium. Pair of medium is same. Correct. So how much it will bend towards the normal? Same in the same extent it bends away from the normal also. Understood? No? How much it will bend towards the normal? The extent it bends towards the normal will be same the extent it bends away from the normal also. Here. Okay. So this is the incident ray now. So it bends away from the normal. Like this. So if you observe, this is the incident ray actually. If you extend this incident ray and the emergent ray, this ray which is coming out, we call it as the emergent ray. So if the incident ray would have traveled in the air itself, it would have come straight line like this. Okay, this is the emergent ray. When you keep the glass slab, it comes like this. If you observe, these two will be parallel to each other. Again, I repeat, see. So this is an incident ray. First, light bends towards the normal here. So this refracted ray will be the incident ray for the second time. Now it bends away from the normal. So this is the emergent ray which comes out. This is the emergent ray which comes out of the glass slab. Think this is the incident ray. If there is no glass slab, it will come straight like this. This is the incident ray. Just imagine, it would have come straight, correct? So that incident ray, if you extend and see, and this emergent ray, if you observe, they will be parallel to each other. So, but there will be some shift here. Okay, so that shift, they call it as lateral displacement or the lateral shift. Okay, why they will be parallel to each other means, if you observe, what is the reason is one time it bends towards the normal, other time it bends away from the normal. Since the pair of medium is same, air to glass, glass to air, so the bending towards the normal and away from the normal, there the extent will be same. That is why that emergent ray will be parallel to the incident ray. But there will be some shift. That shift we call it as lateral displacement. Okay, they sometimes ask like what is the phenomenon of lateral displacement and all.
Here we will end the today's class. Do not forget to subscribe the channel. If the content of this channel is useful, please like the video and share with your friends. Thank you.